Welcome to the notes for Expo 9.2a. Our objective is to graph quadratic functions of the form y equals ax squared plus bx plus c. The difference between yesterday's graphing and today's is that now there will be trinomials that we're graphing instead of binomials. So we'll talk about how that makes some changes for some of the steps that we need to take. First, some review from 9.1. Feel free to pause the video right now. Make sure that you can get all of these correct. When you look at an equation like y equals negative 4x squared plus 7, when it asks if it opens up or down, you need to know if there's a negative out front. This time there is, so this equation will open down. It'll be a frowny face. Wider, narrower, are the same as y equals x squared. The 4 right here in front of the x squared tells us that this is going to be skinnier or narrower than the regular x squared graph. Any number that's bigger than 1 will make the graph narrower. The fractions will make the graph wider. The plus 7 moves the whole graph up 7 units. The vertex will move up 7. All right, let's look at the new stuff today. In a quadratic function y equals ax squared plus bx plus c, the value of b affects the position of something called the axis of symmetry. So this is something that's new today. Yesterday we made a little table of values, and I always told you to put 0 in the middle, and then like 1 and 2, negative 1 and negative 2. This was where our vertex was all the time. Now our vertex is not going to be at 0 anymore. X equals 0. Not necessarily, at least. When there's a b term, we have to use an equation. I'm going to write it down. I want you to write it down, and I want you to highlight it or put a box around it in your notes, whatever is easier for you to do. So here's the equation. It's x is equal to negative b over 2a. That's a really important equation for us today. I'm going to highlight it as well. This is something that you just have to know. Okay? So you have to know that in order to find where the axis of symmetry is, use the equation negative b over 2a. Here's what an axis of symmetry is. So here's a graph down here. Here's a parabola. Okay? An axis of symmetry is a vertical line that would go right down the middle of the parabola. That is what the axis of symmetry does. So the vertex is going to live on the axis of symmetry. So the vertex is always going to be on the parabola, but the axis of symmetry goes right through it every time. So we just have to find where this red line is. The equation for this line is x equals negative b over 2a. And we'll practice using that here in just a second. But you have to know that highlighted formula. To find the x-coordinate of the vertex, that's what you look to do. The x-coordinate of the vertex is at negative b over 2a. Okay? And then you plug that in to get some y. Okay? So I guess that's all I'm going to write, actually, is just negative b over 2a. It didn't ask us about finding y yet. Okay? Negative b over 2a will give you the x-coordinate of the vertex. That should be a 2. Okay? The y-intercept is what you get now when you plug in 0. Okay? You plug in 0, you get some number y out. Okay? Really, I'm going to actually put it as a c, because it's going to end up being whatever this number is. Okay? Is where it'll hit the y-axis. All right, so let's go through an example of actually trying to use this. Okay, we're going to graph the equation x squared minus 6x plus 4. So when we do that, first thing we want to do is identify what a, b, and c are. So remember, here's our form. A is the number in front of the x squared. B is the number in front of x to the 1. C is the constant. So there is no number in front of the x squared, so I'm going to put a 1 there. That's what a is. B is negative 6. Make sure that you notice that I took the negative sign with it. and then C is positive 4. All right, step 2 will be to find the axis of symmetry. X equals negative b over 2a. B is 6, or sorry, negative 6. So negative 6 over 2 times 1. Just plugging in b and a. Well, up top I have a negative. I have 2 negatives in a row. Negative times a negative is a positive. So up top I would have 6. On the bottom I would get 2. So what happens here is I can do 6 divided by 2 and get 3. So the axis of symmetry is at 3. That is the x-coordinate of the vertex. The y-coordinate of the vertex, what I need to do is I need to plug in 3 for x. Okay? When you do that, let's see, here's my equation again. X squared minus 6x plus 4. So instead of x, I'm going to put 3. 3 squared minus 6 times 3 plus 4. Okay, that gives me 9 minus 18 plus 4, which gives me negative 9 plus 4, which is negative 5. So that's the y-coordinate of the vertex. So the vertex is at 3 for x, and negative 5 for y. I forgot to do the negative sign. Okay, well, we found x was 3. We just plugged in x and got y, which is negative 5. So the vertex is at 3, negative 5. Okay, so yesterday I was talking to you about making sure you had 5 dots. I'm going to make that a little bit easier for you today. The vertex is at 3, negative 5. That's one of our points. The y-intercept is going to be when you plug in 0. Okay, when you plug in 0, that our equation is 0 squared minus 6 times 0 plus 4. Okay, what's always going to happen is when you plug 0 into these first 2 terms, they're going to cancel. So the y-intercept is always whatever c is. Okay, so this is going to be 0, 4. Okay, remember the y-intercept, you always want to use the y-intercept since it is always 0, c. Okay, then we just pick some other point that's easy to plug in. You want to make sure your point is easy to plug in. So one thing you can do is you can use numbers like the number 1. Okay, and you can see how easy the number 1 is to plug into certain things. Okay, you could use numbers that are close to the vertex. So you could use like 4, or you could use 5, and you could plug those numbers in. Okay, all those types of things will work. So let's go ahead and plug in 1, just because that's a nice point to try to plug in. We get 1 squared minus 6 times 1 plus 4. Okay. So with that, you get 1 minus 6 plus 4, or negative 5 plus 4, you get negative 1. So at 1, we're at negative 1. Okay? All I'm going to have you do is find these 3 points today before we go to the graph. So we're going to get the vertex with that equation that you need to know. We're going to get the y-intercept because it's always super easy to get the y-intercept. And then we're going to get some other point that's easy to plug in. Sometimes it's 1. Maybe it's 2 sometimes if you want to try to avoid decimals, things like that. Okay? All right, it says step 5, graph the vertex, y-intercept, and your other point. So let's do that. So we need to graph the 3 points we just had. So we're supposed to have a point at 3, negative 5. Okay, so there's my vertex. The y-intercept is at 0, 1, 2, 3, 4. And then my other point is at 1, negative 1. Okay? So here, you might be wondering how we're going to get the U shape out of this. And it's a little bit unique now. Here's what we got to remember. There is an axis of symmetry that we're going to try to reflect over. Remember, here's my vertex. There's a vertical line that goes right through the vertex. And that's where our symmetry is. That's where we have symmetry. So here's what that means. This point's going to stay the same, the vertex. But see how this point is 2 away, 1, 2, from the line, the vertical line, the axis of symmetry. That means I could put another dot 2 to this side. Okay, these two have the same distance. Okay, this dot that I'm making green is the same distance from the red line as this dot. Okay, so what I'm doing is I'm reflecting. I'm just going to count how far am I away, 1, 2, 3, and I'm going to go the exact same distance away on the other side of the line, 1, 2, 3. So here's a dot, now I have 5. So instead of making you plug in more numbers, we're just going to say, you know what, we know that that red line is where I could fold the parabola in half and have symmetry. So that means I can use that knowledge to my advantage to not have to plug in so many things. So that was step 5. You graph the 3 dots that you know, and then from there, you try to reflect over the axis of symmetry. We'll do this a couple more times to get you some practice. So let's go and try another example. Here's our new one. Okay, remember step 1 is just going to be to find A, B, and C. For this one, A is going to be -1, B is going to be +4, C is going to be -2. All right? The axis of symmetry, okay, is the equation -b over 2a. Okay? B is 4, so I'm going to plug in 4. 2 times a, which is -1, okay, is plugged in now. So up top I have -4. On the bottom I have -2. -4 divided by -2 is +2. So that's my axis of symmetry this time. So that means I'll have a vertical line through x equals 2. The vertex, I need to plug 2 in to my equation. So that's what I'm doing here. Plug in 2 for x. I have -2 squared plus 4 times 2 minus 2. Okay, the negative is outside the parentheses this time, so a little bit tricky. So I have 2 squared here, which is 4. So there's still a negative out front. I have -4 plus 8 minus 2. So I have -4 plus 8 giving me +4 minus 2, I get 2. So that's my y. So the vertex is at 2, 2. Okay, that's how it worked out this time. 2, 2. Okay, so that's going to go right here. The y-intercept is when you plug in 0, but what you always get out is the c term. Okay, so the y-intercept is going to be at 0, -2. I'm going to pick one other point that's easy to plug in. It's nice to plug in 1 sometimes just because that's a number that's not very big, and plugging in 1 usually goes pretty well. Negative outside the parentheses, 1 squared plus 4 times 1 minus 2. Out here we have -1, we have +4, and -2. So we have -1 plus 4 giving us 3, 3 minus 2 giving us 1. So it looks like that's what our equation is going to be this time. 5 will be to graph those points. Remember that I have a vertex at 2, 2. I have a y-intercept at 0, -2. I have an other point at 1, 1. Okay? The axis of symmetry goes right down the middle here. Okay? Goes right down the middle of the vertex. The vertex does not get reflected, but this point, which is 1 away from the blue line, I need to reflect over to this side of the blue line. This red point, the y-intercept, is 2 away from the blue line, so my other point will also be 2 away, and now I can make my parabola from there. Oh, I might have missed on the first example the domain and range. I apologize for that, but we can do those now. The domain is always going to be all real numbers, like we talked about yesterday. The range, we have y, and then we look at what the maximum was here, the y value of the vertex. Remember, this was 2, 2. Okay, the y value of the vertex is 2, and that's a maximum, which means all the y's on the red parabola will be less than or equal to 2. All right, we're going to go one more time. Last example, I want you to pause the video and try these steps so that you can check your work right away and make sure you're doing it right. So go ahead and pause the video now. All right, you should have tried all these already. Step 1, you should have had that A was 2, B was 8, and C was 1. All of them were positive this time. The axis of symmetry is negative B over 2A. Okay, negative B is 8. A is 2 times 2. So on the top we have negative 8. On the bottom we have positive 4. Negative 2 is our axis of symmetry. That's the x-coordinate of our vertex. When we plug in negative 2 to find the y-coordinate of the vertex, we have 2 equals 2 times negative 2 squared plus 8 times negative 2 plus 1. Okay, what we get with that, negative 2 squared is positive 4, so I have 2 times 4, which gives me 8. 8 times negative 2 is negative 16, and then I have a positive 1. I have 8 minus 16 plus 1, that's going to give me negative 7, so y is negative 7. So the vertex is at negative 2, negative 7. The y-intercept will be at 0, 1. Okay, find one other point that's easy to plug in. Maybe the point 1 is nice. Okay. And what we can do then is look at plugging in 1. So 2 times 1 squared plus 8 times 1 plus 1. So this is 2 plus 8 plus 1, which is 11. So at 1, we're at 11. Okay. All right, so our vertex is down at negative 2, negative 7, negative 2, negative 7. All right, down here, our y-intercept is at 0, 1. And then we have at 1, we're up at 11, which is just over the top of the graph. Okay, here's our line of symmetry. Okay, this point needs to be reflected 2 over. This one up here at 1, 11 is 3 away, so I need to go 3 to the left and put a dot up at 11. And then there's my parabola. Okay. The domain is all real numbers. The range is going to be a greater than this time because I have a minimum here. The smallest y ever got was negative 7. So hopefully you're able to do some of those steps correctly. Go ahead and try on the assignment to get some of these done. It's a bit of a process, but if you can remember negative b over 2a, it seems to go pretty well. All right, have a great day.